Assalamualaikum warahmatullahi wabarakatuh. My name is Red Alfi, student from the Department of Electrical Engineering Education from the Indonesian Education University. In this video, I will introduce the research that I did at PT.Syergie Indoprima Bandung in general, with the research title Designing MQTT Data Communication Control System using STM32F429Zi Microcontroller based on Fiber Optic Transmission Media. I tried to make this video so that my friends can understand clearly but briefly. For the tutorial stage, I will share several indicators and I will simulate each indicator. We enter into the first discussion. According to the title of the research I made from my friends, I will introduce one of the communication media protocol, namely the MQTT protocol. The meaning of MQTT protocol is a communication protocol that operates over a publish or subscribe based TCP or IP, specifically designed for a communication between low power devices. This protocol can transmit data such as binary, JSON, and XML. In its use, the software components are needed, namely MQTT client and MQTT broker or server. For simplicity's sake, by using this MQTT protocol, we can control two devices. You can see in video. We can control two devices remotely with many input and output topics with the same IP address. You can install a MQTT Mosquito and activate easily from the other video tutorial. For the transmission media, it can be used with Ethernet or optical fiber. However, the transmission medium that I use in this research is optical fiber, which is I will explain after in the next discussion. For more details, I will simulate publish and subscribe to MQTT protocol via the command prompt. You can see from the following simulation from this video. In this simulation, I open the command prompt and you can see from the left side Mosquito pub is meaning MQTT publish, and the right side Mosquito sub is meaning MQTT subscribe. Mosquito sub has a job for the receive message, and MQTT publish or Mosquito pub has a job to send a message. I use the IP address of the Wi-Fi or your server. You can see of the hosting. My hosting is 127001 for publish, and for subscribe I use 127001. It's the same of both. And the topic I use same of both game. For the topic is test to publish and test again to subscribe. I will enter to subscribe. Because down to configure, and I will try to message hello. If message hello send to subscribe, you can see to subscribe receive to hello from the Mosquito pub. The message hello that is sent is received in less than a second. This means that the simple communication to publish and subscribe of the MQTT protocol is successful simulated. Okay guys, go to the next discussion. The most important indicator of this research is optical fiber as the transmission medium. Why should I use optical fiber? You need to know, based on several studies that I have been done, optical fiber is the most effective transmission medium when we transmit data with latency is less than a second, and it has been proven, friends. The efficiency of optical fiber is superior to Ethernet for a long distance transmission of scales. Although the circuits same made in this study still use Ethernet, it will all be covered with the help of a converter into optical fiber, which is I will discuss in the next discussion. From the PowerPoint, you can see I use Indonesian language for the part of the optical fiber. You can see core, cladding, clothing, and auto jacket. For more details, you can see of the book on our internet. Continuing to the next discussion, the next most important component is the Ethernet to fiber optic converter, which has the function of converting an Ethernet cable into optical fiber that is connected between a PC and microcontroller STM32F429Zi. You can buy this converter cheaply through any platform with any brand depending on your needs. The installation itself is relatively easy. You can see in this picture. For this converter, there are two types. Type A from the left side and type B for the right side. For type A, on the left can be connected by Ethernet and optical fiber to PC. Then, for type B on the right side, it can be connected to microcontroller STM32F429Zi. When the two converters are connected to voltage source, as an indicator, you see the light green. You can see of my video. If connect, the light indicator green for type A and type B is on. And it's meaning the converter is ready to use. Moving on the last indicator, I will introduce to you all a microcontroller which is still rarely in Indonesia, namely STM32F429Zi. This microcontroller is made by STM Microelectron, which has a program system that is almost the same as other microcontrollers, but is more efficient in terms of power saving and is compatible when connected to Ethernet transmission media, so that this microcontroller can be used as an IoT device. For more details, you can see from the video regarding the following STM32F429Zi specification. You can see from the monitor the datasheet from STM32F429Zi and features in hardware and specification from input voltage and output. You can see and you can read this specification step by step. After explaining all the indicators needed in this study, then I will discuss from the basic of the title back. The data communication design came between the PC and microcontroller STM32F429Zi so that they can control the lights on the microcontroller with MQTT box as broker and interface. can be seen from the design scheme in this video. From the PC, we connect it to Ethernet and the converter A and convert it to optical fiber. This arrow has meaning to optical fiber and Ethernet cable. From the PC, we connect it to Ethernet then a converter A, which is followed by converter B, then convert back to Ethernet, which will later be connected to STM32F429Zi. In the same, you can see an image of a joystick and a robot. Joystick has a job to control a robot, but this will be contained for further research. Then you can see also in the middle of this, there is the MQTT protocol for the controllers with or a LED control program using the Arduino Uno. After we program and we connect to MQTT, the LED from STM32 red light can on or off and just send a message from publish MQTT on or off. If on, the LED right from the STM can on, but if I send message off, the red light from the STM will be off. Okay, next, after explaining the indicators, installation scheme and design have been made. You can see from my PowerPoint before, I continue with the programs that have been made in the Arduino IDE programs, which will later be compiled to the microcontroller STM32F429Zi. I will explain step by step how to make a program to control LED on or off in the microcontroller. First, you must programming the IP address as a client, which is obtained from the IP address that is already connected between the PC and microcontroller. It can be seen from the video that I use IP address to become a client, IP address as IP and IP address as server. And the second step, I program several topics. You can see from my program, topics is string message wheel 1, wheel 2, message cloud, jet pump and flow control is a topic, so that in the void part, you can see the void part, void callback, of the topic callbacks that have been programmed can control the LED only by the on or off topics command. For them, I remind you not to forget to install the required libraries, such as program I create. The libraries can be found online the internet, like libraries PubSub client, STM32 Ethernet, SPI, and LVIP.H. Before that, I will explain the topics from void callback. In this program, you can see if the topic string will left, if message I control on, digital right, LED red hide, and if else if message wheel 1 off, if I send message off, and in the subscribe serial print on off, and digital right, LED red or low. From the topic wheel 1, wheel 2, wheel close and jet pump and flow control, the program is same. It's just a dummy data. After the topic, we register subscribe to client. You can check in void read connect. While client connect, serial print attempting MQTT connection. If client connect, controlling client. Client subscribe, will write, will left, will forward, will stop, close up, and close down. If I publish, will write, and the topic in subscribe will write. If I send message on, the length is high. If I send off, the length is low. Same as the topic will left and etc. If I send a topic on or off, the length in microcontroller, if I send on, is high, and if I send off, the length is low. But the topic between subscribe and publish is the same, and IP address from the programs, IP and server, register to MQTT box as MQTT broker or interface to controlling the length. And the third step, you can compile this program and you can wait to after finish. Alright guys, enter the final stage of the research this time, namely the result of the simulation that have been made. After the programming has been successful upload in Arduino IDE programs, the program has been finished compiled. You can see the simulation results that I made with the MQTT interface using MQTT box. I will open the MQTT box. After I open the MQTT box, this is MQTT box, you can see in my monitor. I will configure MQTT box with the same IP address or host from the programs has been compiled. With the same IP address, you can look the IP address in host and protocol MQTT TCP. You can see MQTT host is 192.168.22.24. It's the same in my program. Is IP address server. If finish program and configure an MQTT box, if I save this configure, is been automatic connect. You can see in my result simulation in my PowerPoint. Look, this configuration MQTT box, and you can see what the simulation result. If I make topic to publish and subscribe, blue is publish and orange is subscribe. You can see the topic of publish. I take one topic in my program, one of 7 topic. Just example to simulation. You can see the topic. If I send a topic will forward, and the subscribe same will forward topic. The topic QoS or quality of service is 2. It means message already to receive and send. If I send is live to receive. If I send on a message pilot as message in publish, and the subscribe receive message on. And you can see from my microcontroller in here, the LED write is high or on. And if else if in programs, if I send a message off, you can see in topic is same meaning, will forward again. You can see in microcontroller is low, right? Is right and is low. That this means that the process of the control design came between two devices, PC and STM32F429Zi. In this research was successful carried out. As the closing of this video, a brief conclusion that I can draw is that with this research you can apply it the various other data communication concept using IoT. With this research, data transfer is very easy to design and simulate based on any program as needed. For your own device, you can use other device with specifications that depends on the device you have. As example, if you have an Arduino Uno, you can use Arduino Uno. If you have a ESP32 or ESP8266, you can use the ESP. And that's all from the video discussion of the research that I made. Hopefully all of you can take knowledge from the discussion that I have made and can apply it. And hopefully from this video we can advance data communication technology so that the knowledge and experience gained can be useful for the advancement of education and technology in Indonesia. That is all. I apologize for if there are definitions that are not understood when I explain from material. And at least but at least, wassalamualaikum warahmatullahi wabarakatuh.